Hi, my name is Amanda Herman, and this will be my video explanation of the structure problem solving process. So I was in group 1, so what they gave us was this as the proposed structure. So the following problems says use the tables on the following pages to show your work. And so first we look at the IR table, and so I found, sorry you can't really see, but I found that my frequencies were about 1740. I found a peak there, and then I found one at 2980 as well, and then at 1180 as well. And so that's when looking at it right here. So when looking at it right here, so this is the peak at 2880, around there. That's gonna have a carbon and hydrogen stretching alkyne chain, I believe is how you pronounce it, and it's gonna be an sp3. And then so the next one was at 1740, so right here. That's going to be like a carbon and double bonded to oxygen. It's going to be an ester group, and then it's going to be stretching. And then this one right here at about 1180, that one's going to be carbon single bonded to oxygen, and it's just going to be a stretch. Okay, moving on. The next one is the 13C NMR. That's that table that we did. So right here, this table. So the chemical shifts that I found right here. So the first one was at 175, about them, ppm. That's going to be a carbonyl double bonded to oxygen right there. And then the next chemical shift I found was 60 right there. And that one's oxygen single bonded to carbon hydrogen 2. And then, or CH2. And then the next one into it, that's approximately about 38 ppm, and that's going to be CH2 as well, that it's the bonding environment. And then the next one right here is going to be 20. That's also a carbon or a CH2, as well as 15, which is right there. That one's going to be bonded, the bonding environment of CH3. And then 14 is right next to it, super thin, you can't really see, and that's also going to be CH3 as well. And then the next part is the 1H NMR. So the first, so put this down. So for the first chemical shift, I found one at 0.9, and the integration is going to be 3H. The municipality is going to be a triplet, and the interpretation of it is going to be CH3 attached to CH2, CH2 and C, and then, or single bonded to CH2, another CH2, and then CO. And so then the next one next to, or the shift next to it is going to be 1.2. That is, the integration is 3H. It's also a triplet. And then it's the interpretation is on CH3, which is single bonded to CH2 and then single bonded to oxygen. The next one onto the side is going to be 1.6. I'm sorry, you can't see 1.6. These are all just approximates for 1.6 ppm, and that's going to be 2H. It's going to be, I think it's pronounced multi-pellet. That's going to be on the CH2 interpretation. That's going to be single bonded to CH3, single bonded to CH2, and then single bonded to CH3 or CO. The next shift is going to be 2.3, which is about right there. Integration is 2H. It's a triplet, and then the interpretation is going to be on CH2. And then the last one is a 4.1 chemical shift. Integration 2H. It's going to be a quartet, and the interpretation is going to be on CH2. And so my proposed structure, I believe it was pronounced ethynyl butyrate right here, or ethane or ethyl butyrate. That's my proposed structure for it. So kind of explaining how I got these. When like interpreting, I guess like the or the 13C NMR, I just know that like the chemical shifts are like a single bond of 2 carbons is like 0 to 50. single bond for carbon to oxygen is like 50 to 100. Those are the chemical shifts we learned. So that may help me interpret that diagram. And then just knowing about like how to interpret, sorry, I'm just looking at my notes real quick, like how to interpret origins or frequencies and stuff and like fingerprint regions when looking at the IR. Just knowing that like what the wavelengths are, if they're back more or if they're forward more. And then the interpretation of the peaks with the 1H, that's just using like the first order pattern that was taught and everything like that. So thank you.